All right, everybody, let's get this party rolling. We're here for a very educational webinar on measuring quiescent currents, easy ways to do it and difficult ways to do it. So I'm Richard George here with Accurate Technologies. I'm joined by two esteemed colleagues, Tom Berettas.
Hello, everybody.
And Jeff Kitka.
Hello.
And since I've got this powerhouse of expertise here, I think we're going to do this more as a little ask the experts here, and maybe we'll banter a little bit about some of these ideas, and everybody will learn a little something here. I hope so. Quiescent current is it's kind of a weird word, and it comes up a lot, and people ask us about how to measure it and why. It's important for a number of reasons here, especially as vehicles are getting heavier electronics in them. Your battery health is critically important to these vehicles. You've also got the performance of the electrical system. You've got a fuel efficiency question. Naturally, if your batteries are getting run down unnecessarily, next time you go to use your vehicle, you've got to recharge those batteries. And if it's a battery vehicle, now it's even worse because now you've lost range because you're losing power while the vehicle isn't maybe being used or sitting idle. As a matter of preventive maintenance, it would be wise to make sure you understand the health of your vehicle, have issues with drawing excessive current while it's idle, not being used. And of course, as a diagnostic tool, you would do current measurement when you're trying to figure out exactly what is going wrong and what is the cause of it. So there's a number of reasons why this current measurement is really critically important in our industry. The term quiescent, strange word, but it refers to a state of inactivity or quietness. I think its base is quiet.
Over some other markets, I believe in Germany, they might call this sleeping current.
That's right.
As well.
The sleeping current. We do run into language barriers sometimes, even with our other English speaking.
A little bit. We had to explain to some of our German colleagues what the word quiescent means. And they're like, oh, it just means sleeping. Yeah.
I ran into a similar problem with the word fascia. We think about fascia being like the front of a car.
Right.
When you go to England, the fascia is the dashboard. And I asked why. And they said, well, because that's the part of the car that faces you.
Hey,
that's why they call it the fascia.
That does make sense.
I guess. Quasi-logical. So I'm not intending to read every word on this presentation, but the presentation will be available for everybody later. They can go through and look at it and refer to it after they've forgotten 90% of what we talked about and they want to come back and get a refresher, or for people that just grab this a year or 2 years from now, they can go through and read all of the words. All right. So what are some of the components here that contribute to these quiescent current draws? These are just some of the things I came up with. Maybe you guys have some other ideas, but here's a few of them. I try to break them up on a couple pages because it just looked like a huge list of things. But of course, you know, vehicles have tons of modules in them now. This is just like a start of a few of them. But you got your engine control modules, body control. You've got all of your entertainment systems that are in there, radios. We're going to talk about components that contribute to these current draws in your vehicle. You got all your control modules, of course, entertainment systems, which are radios, infotainment, nav systems. A lot of these things are always in standby mode. Security systems, of course, are always on, especially when your vehicle's off. That's the whole point, right? Other accessories, your OBD systems, instrument clusters, has obviously a memory that needs to maintain your settings and all that fun stuff. And vehicles have a lot of telematics in them now too, where they're checking to see if there's software updates available. And they do this stuff not just when you're driving the vehicle around, but they do it all the time.
That and proximity things too. A lot of newer cars now, as you get close to the vehicle, it might have the option to unlock
Absolutely.
or turn the lights on.
Which makes for a difficulty in checking your quiescent current,
Right.
because if you're needing the vehicle to be in its sleep mode, and to see what kind of current draw you have. And then if you've got the key in your pocket and you go up to the vehicle to then do some testing, of course, now the vehicle wakes up and you just ruined your test. So you have to make sure that you keep the keys away, because they are always looking for you approaching, and then to boot things up and have them ready for you. Turn on some lights so you can see where you're going. Maybe deploy the running board so you can get in. Things like that. So, of course, all these vehicles are going to cause a battery drain. The concern is whether you have an excessive battery drain, one such that when you leave your car off for a few days, now your battery's dead and you can't start it. I do believe they intend to have vehicles be able to tolerate being left unused for 2 to 3 weeks anyway, without a problem. Maybe 4 weeks would be a reasonable target for a vehicle. So if you have your car sitting for 6 or 7 days and the battery's dead, there's either a problem with your battery or there's a problem with the current draw. Right? And we're going to talk about how you can find the source of that current draw. That's why we're here. But of course, this does assume that your battery health is good. Now, if you discharge your battery to a lower level than what it would like, especially multiple times, that can lead to serious battery problems. And now your battery may be faulty and unable to maintain a reasonable charge, although it may not be the root cause of your problem. Right? It may now be a symptom of being because it's been discharged deeply multiple times, and now you need a new battery. Oh, my battery's just going bad. Maybe you have another issue in the vehicle. Needs to be diagnosed and solved. Otherwise, you'll just be going through a lot of batteries, and that's not cheap. Of course, that puts an extra strain on your charging system as you discharge that battery and have to come through and charge it back up. So it's hard on your whole vehicle. So there's a couple ways that you can measure this. We're going to look at two main ways. One would be using a shunt for measuring the current that your vehicle is using. That would be a traditional way. Shunts have been around for many years, very common in the industry. So we'll talk about how you'll go through and install one of those. And we also have a much simpler way using some newer technology and an inductive style current probes. But you need to understand one in order to understand the other. So we're going to go through both of them. Shunt measurement would also be similar to if you were going to use a multimeter or a current meter that you could just hold the probes on and measure the current. But with a shunt, you can have a semi-permanent installation and be able to monitor or record your current draws without you having to stand there holding the probes on a couple wires, right? So it's a slightly more professional way, and the way that we would see vehicles be instrumented at least in the past, and still currently there are some cases where a manufacturer would install some shunts to monitor current draw during a pre-production or development phase of a vehicle. Shunts come in a number of different sizes, so you need to select a suitable one because you're going to only get a certain resolution for that shunt based on its range. So you could get yourself a nice 500 amp shunt that would cover most anything in the vehicle, but then if you're looking for a couple of microamp draw, it's going to be very difficult to discern that in that large shunt. But if you opt for a 10 amp shunt, you'll be able to look at those very small amperages, so a little simpler.
Sensitivity of the lower amperage measurement devices are usually a little bit more accurate.
Exactly.
Down to the lower numbers.
Yep. Well, ultimately, a shunt, you're measuring a voltage drop across a resistor. So that gets a little difficult if you have a very low ohm resistor and very, very small voltage drop then, because you have a very small current going across it. So once you've got the shunt, which can be physically large, and that packaging can present some problems with installation also, you also have to identify which circuit you want to install it on. And you get to install it on one circuit only. That's it. So you've got to pick the right one.
And this is typically destructive to the harness. You will be physically cutting the wires, installing the shunt, heat shrinking everything, wrapping it.
The key point is to disconnect the power before you go cutting those wires. You can be in for a shock, literally.
Yep.
So you have so you do have an issue where you'll need to be disconnecting all the power from the vehicle. Once you've identified the circuit that you want to get to, you're going to need access to it, which may mean unwrapping a harness in order to get in there and be able to physically make a cut to the wire that you need to be measuring.
I've seen this done too, where the harness is actually physically removed from the vehicle and laid on a table.
Yes.
And then you go through and do everything. So you
that's not a 15-minute job.
No. No, that's a solid 3-4 day job.
Yeah.
Depending on what you're working on.
Technician time.
Right.
Which is not the cheapest time.
Right.
So yeah, it can be quite expensive to do this nicely. And if you have a vehicle that's going to be doing extended testing in real world environment, you need to do that sort of installation. You can't just cut the harness, crimp a couple ends on, and throw your shunt in. Maybe you can do that for just some minor testing inside your shop, but the vehicle is going to be doing some extended testing or out in the real world.
Yeah, and part of the installation too is the packaging, because like the picture you had previously of a shunt, most of them are bare copper pieces.
Yes.
Yep.
So you have to put them somewhere or protect them somewhere, which this becomes a safety issue if you're trying to do this on a high voltage system.
It's a safety issue on a 12 volt. If you look at that one right there, somebody could accidentally not just lay a wrench across those two terminals, and maybe, it wouldn't be the best thing in the world. But, I also have problems with technicians and wedding bands, accidentally arcing between a positive lead and the ground, which can cause tragic damage.
Even if you put the shunt on the low side of the circuit, you still have a circuit going through there.
You still have a circuit. Yep. Exactly.
Twice as line.
And too, if anything does go wrong, when those leads comes undone, when your crimp points comes undone, you're tearing the harness open again.
Mm-hmm. You're also introducing some other resistance in the circuit by, say, you're only using crimp-on connectors for your shunt, which wouldn't be an unreasonable thing to do. It's a very temporary installation, but there's a little resistance there. And what if you didn't crimp it real nice?
Right.
Now you can be affecting your measurement because of the quality of your installation. So that's another thing you have to be cognizant of. But let's say you get all that stuff done. I don't mean to poo-poo shunts, but they are there's a little work to install, and they have some risks. But once you got that all in, then you can connect to your test leads. Basically, you're going to measure a voltage across the two terminals, which you could do with just a lap scope or even a multimeter. But typically, we would see somebody use some sort of a data acquisition system to be able to log and record that voltage, because maybe you don't want to be standing there staring at it the whole time, waiting for things to happen, and you're waiting for your vehicle to go to sleep so you can measure a quiescent current. It would be nice to hook this up, start your DAC system, and then go do something else for half an hour instead of just standing there, right? So oftentimes you'll see some sort of a DAC system would go. You'd be measuring that as an analog voltage. And like we saw before, here's a picture of a typical higher value, higher amperage range shunt that could be put in place to measure, maybe with that wiring, probably a 15 or 20 amp circuit, but that shunt could probably handle a little more also. So once you've got all that installed, you've got your DAC system or your oscilloscope connected, you can repower the vehicle. You're ready to go and put it in a mode where you maybe are suspecting there's an issue with a current draw, right? So you can monitor that. Now you're going to have a voltage range across the shunt. You'll have to convert that into amps, which most DAC systems could handle that for you. Maybe you'll have to do it, yourself and do a little arithmetic on that voltage measurement that you're getting and determine how many amps that really is. Once you're all done with your testing, assuming you found your problem and corrected it, now you get to undo all of your good work and put the vehicle back to a normal state, which is going to require some repair to the harness, of course, because you cut it, and you're going to have to wrap that up nice, make sure it's going to be a good durable fix. It's one thing if you're doing this to your own vehicle. It's another thing if you just rented something from Enterprise Rent-A-Car because you needed to test a certain vehicle and that was the way you could get it. And now you've done this. And if Enterprise Rent-A-Car, for instance, knew that you had been slicing up their harness and taping it back together, they probably wouldn't be thrilled.
That would not be your car.
Yes, or it could be a vehicle that, you know, a company could purchase a vehicle for doing this testing to make sure things are going right, and with the intention of reselling it when they're done. That happens a lot. Well, now the vehicle's not really the same as when they bought it.
One of my previous occupations, doing brake system development, and we would, you know, the company would go out and buy a new vehicle, but we would completely replace the entire analog brake system.
Yeah.
Computers, hydraulic lines, ABS motors, everything. And then when we're done with that program, you know, there was a question of like, can we throw it on Auto Trader?
Sure.
But and I think some of the legal team was like, no, you really can't. Even though it is technically back to stock. Yep. It's not something that they wanted to be liable for. So it was still sold, but it was sold internally with a waiver.
Yes. Yeah. Yes. Yeah. You have to sign this piece of paper.
Yeah. So just another thing that kind of adds up to the complexiveness of using a shunt style measurement.
Yep. Yeah. Yep. And of course, if you're unsure about doing any of this work or whatever, you do need to seek out the help of a qualified technical person or technician, to help with this. We wouldn't want people just willy-nilly slicing up wires in their car because they are concerned as to why they're going through batteries every 3 months.
Right.
So you do need to have some caution. Now, if we want to look at some non-intrusive hardware, I think it would be our method, if possible. We could do an inductive current probe. For example, we're showing, or we're going to be discussing here, I do have a picture also of this CANWAY current probe. These are great little inductive devices with a single point connection to them, and they send their data out over CAN, which makes it very simple to collect. So similar to your shunts, you would need to select a probe for your proper range. There's a number of ranges available going up to 1,000 amps. So these are even suitable for EV applications. Once you've identified, of course, your proper probe you're going to use and the circuit that you're going to connect to, you place the probe over that target wire. Depending on the size of the probe, the smaller ones are a little thinner, so that they would need less wire access, and you may need as little as an inch of wire in order to slip this probe over and be able to measure the current flowing through that circuit. So very simple. Even if you do have to strip back a little bit of a harness protection tape or convoluted tubing, it's very minimal, much less than you would do for a shunt. So way better. Once you've got that slipped over a wire, you'd start your CAN-based data acquisition or analysis software or CAN data logger. As soon as you power up this probe, it will be sending data out to your DAC system. So you don't need to press any buttons on it, tell it to start, tell it to stop. You power it, it will be measuring and sending out data.
Yep. So. And it's powered up. Well, obviously it's powered up when you power it up, but it's programmed right out of the box as well. There is a configuration software that does kind of come along with this CANWAY clamp, and that'll allow you to change the CAN ID, add a filter if you need any kind of filtering on the signals coming out of the thing. The ability to export a DBC file, which is obviously it's necessary. Otherwise, it's just going to be spitting out raw CAN data. So you would need to launch the software. It's very easy to use. Once you're connected with the CANWAY USB adapter, you'll be able to see it in the software. Software will talk to the device. It'll already know what it is, and if everything looks good on your end, one button click, export a DBC, and you can import that into whatever data acquisition system that you want.
Yep.
It runs a standard CAN, not CAN-FD, at least for now. So really, any software that can interpret a CAN message and work with a DBC, this will work for you.
You will need some sort of a CAN adapter to get this CAN data into your PC for your data acquisition software. A variety of options there. CANWAY does offer their own also. But the great thing there is you could have multiples of these programs, and they'd run through a single CAN adapter. So you don't need to duplicate every part of the system to monitor multiple points simultaneously. Right? Makes it quite simple.
Yeah, there are a couple different adapter cables. I don't know if we have any pictured in this presentation, but you can chain these together and they'll all have their own unique identifier, CAN ID that is. Yep. And all be within the same DBC file, or might be separate DBC files for each device. But
yeah, you import that in and
pretty much plug and play.
Plug and play. Nice. You've got your data coming in, you record it, then it's a matter of the software you're using, how you want to interpret those results, see what's going on, and find out what kind of current draws you have in different states of the vehicle. This could be quiescent current, or it could even be things that are going on while you're operating the vehicle. Depends on what your test requirements are. Great thing about this is totally non-destructive. If you had to go borrow your buddy's car to do some testing on a specific model, or you rented a vehicle, or your company bought a vehicle for some tests, and you need to do this kind of work. When you're done, you just take your probe off, maybe tape up the wire covering, the protective covering on it. The wire itself will be fine. You haven't done any damage to the wiring. It's just maybe to make it look nice for its protective over shield, and boom, you're done. And no risk to having maybe not done something up to snuff, good quality repair, because you've never done any damage to the vehicle in the first place. And that is huge. That's a huge cost savings, a huge liability, and also look how much time savings it is. Instead of having hours or days of a technician's time to instrument your vehicle, you've literally taken a few minutes.
Yeah. And also, something like this would be great for like competitive vehicle analysis too. So,
yes.
Kind of like you mentioned before, you're not going to go to Enterprise, rent a car, and chop it up.
Yep.
Or maybe you do, but then that's on you. But here you can rent a car for a day, and the most you might be doing is stripping back some wire insulation.
Yeah.
That's usually pretty easy to put back to the the way it was, or even not. If you just wanted to measure everything, you could clamp over the battery cable. That would probably give you way more than what you're actually needing, but going down to
the sensitivity on these is pretty good. You could use a higher amp range on the entire positive cable going to a battery, and you might still be able to measure a very small amperage draw on a vehicle.
Yeah.
And why might you want to? Another reason you might want to do that is you might have been tasked by your employer to figure out whether this vehicle has an excessive quiescent current draw, but you don't know what normal is. So maybe you want to go and find some other samples of a vehicle and test them so that you could have some basis for describing what normal is and knowing whether this one that you're looking at is an anomaly or just indicative of the entire fleet of vehicles. And maybe it's not that something's wrong with this, but maybe you get to point the finger at the engineers.
Right. Yeah, right. Yeah, I think, does the presentation we're using have the recorded data file in it?
There is a screenshot.
Or there's a screenshot of
yes,
it?
there is a screenshot.
Okay.
Yeah. So we'll get to look a little bit at that later. So.
Oh, I got you.
So one of the things that you can do if you, currently battery electric vehicles, most of them still have a 12-volt electrical system, which in many cases, if that dies, the whole car's died. I don't know the exact precision resolution on this, but you could have a higher amperage probe coming off the battery to check all the 12-volt loads. And because obviously there's no super high current draw there to run a starter, which is usually the largest current draw on
Yeah.
ICE motor application. But it would definitely have more than enough precision to monitor the system, especially looking at the fact that how long does it take for everything to shut down? You may not identify the circuit, but what is the quiescent current? When you think the vehicle is put to sleep or should be in sleep, obviously if it's drawing like 2 amps, well, something's not right. You'd have to total up the total quiescent current, but yeah, drawing 5 amps off a 12-volt battery is going to die.
Yeah, pretty quick.
In a while.
Yeah.
And the other thing too is like on BEV platforms is what wakes up when you charge it. So you have a car that's supposedly dead. Now it may try to wake up because you walk up to it with a key fob, so certain things are going to try to fire up, but then you plug in a charging cable. Does every module in the car light up? Because that's going to affect your charging rates.
Yep.
Right.
Or is only certain subsystems. So you can still get a lot of information, not necessarily pinpointing, but you can tell if you have a problem.
Exactly.
If you shut it off and you wait 5 minutes or whatever, and current's down to like 5 milliamps, or whatever it's supposed to be.
Yep.
You're probably pretty good. But yeah, it's really good for validation. And what's nice is it's quick and easy.
Yeah, the reason why I asked about that recorded data file screenshot is we did a demo here. We have a video that is posted on our social media and all that. We used a 100 amp probe to measure.
I must be running off a different version.
Yeah.
Okay.
Probably before, I opened this before you made those changes.
Okay.
That's why.
Okay.
We'll show it here in a
Yeah.
minute, but essentially we used a 100 amp probe to go over not the main positive battery cable in our demonstration, but one of the ones going into the main
Going to the
fuse
power
block.
distribution box.
Yep.
Yep.
And we were able to measure down and actually see, you turn the hazards on and you see the current go up, current go down, current go up, current go down.
Yeah, certainly
And
milliamps.
that's only about 2 amps total.
Can you bring the file up in VGA?
Yeah.
And share your screen?
Oh, yeah. Let me bear with us another moment. I'm going to see if I can share.
Oh, we
my
can talk,
screen.
yeah, while you're getting that set up here to show some real world data. We talk a little bit about, of course, safety and doing any of this testing, which I thought was important. But no matter what you're working with, you should always be disconnecting that power source before you're going in, slicing any wires, digging through things. There's lots of personal protective equipment that's important. If you're doing, especially working on high voltage systems, or insulated gloves, safety glasses, maybe not wearing a metal wedding band while you're doing those, as most technicians would be aware of, because there's always that one guy in the shop who didn't.
Mm-hmm. And when you disconnect the power source on a 12-volt battery, it's advantageous to pull the ground terminal off first.
Yes.
Because if your wrench accidentally bumps the inner fender, nothing bad happens, versus the positive terminal where I've seen a 9/16 wrench get welded to the inside of the car.
One of my safety precautions: avoid short circuits.
And yes, a hard battery will make a wrench turn cherry red.
Oh yes, instantly. Instantly.
It's just there long enough.
Yeah. It doesn't take long. It does not take long. Of course, there can be lots of moving parts. Batteries do vent off gases, especially if they're experiencing high discharge rates. So ventilation is important. And whenever you're working on a vehicle, that whether you suspect some issues here or not with the electrical system, but you should always be inspecting, be cognizant of looking for damage, which could lead you to your source of the problem in the first place. But even with your testing equipment that you're installing, you have some frayed wires, things like that. It would not be wise to use those. Wire is cheap. Leads are not expensive. Replace them if there's any issues.
What we've got here is a data file, and for those of you who might not be familiar with this, this is our Vision Data Analyzer data analysis software. So it's designed to open up MDF4 files along with our some other proprietary files as well. You can import text files, things like that. We're not talking about VDA. That was just a shameless plug right there. Yeah. So essentially, what we have here is a vehicle is what you might consider a sleep. So I've got my cursor 1 here right at the beginning, and I'm showing just about 3.9 amps. The vehicle's probably not 100% asleep, but it's lights are off, doors close, doors are locked, you know, that kind of thing. What you can see here, so we've got this clamp, just like the screenshot that you saw, just over one of the battery cables running into the power distribution block. This is where, I didn't put a note here, but that's where the door was opened. So now I'm up at, if you look up in the top right, you've got 7.9 amps. So a jump just by opening the door.
You got interior lighting and maybe some modules, other modules powering on at that point.
Yep, yep. So as we go down a little bit more, turn the headlights on. So turn the headlights on.
Mm-hmm.
There were a couple more jumps here, not exactly sure what that was, maybe interior lights coming on or something like that.
That's probably like a parking light, then back off, and then headlights on.
Yep, back off, then headlights with brights on. I
Okay,
remember
all
we
right.
did that, yeah, yep. Yep, then we left those on, and then we just turn on the hazard lights. Now this isn't something you'd probably be measuring in the field. You know, this is just a nice little demonstration to show you, you know, exactly, you know, what can be seen here. So as you can see, hazards on and hazards off. So that's showing about 18 amps total, and when the hazards go off, it's showing 12 amps. So we're using a 100 amp probe, but we can still discern a difference in between 18 and 17 amps.
This vehicle did not have LED lights in it. It was an incandescent style.
Incandescent, yep, yep. Which probably allowed us to show this, you know, type of thing so graciously. And this one, I definitely like the way this trace looks. So right here, we commanded the HVAC on, and you can see as the fan ramped up, you've got this nice little slope, and then that's the amperage that we're at now, about 32 amps. As we go down, there's a little bit of a long file. Can't remember exactly what we did here. Maybe turn the lights back on or something like that. Lights on, lights off. And we actually did a crank event too. So you can see, you want to go for it, Richard?
Yeah, well,
Yeah.
so this probe wasn't on the starter current itself, but it's just a current to the rest of the vehicle. So we don't have a big spike from the starter actually running, but you do see all the other electronics in the vehicle, what they were doing. And it actually looks like they turned a lot of electronics off while cranking, you know, and until the engine started and then brought them back on. Right?
And it did actually go negative here. That's probably from the alternator pumping voltage into the battery through everything else.
Excellent point. Yeah, it was actually recharging that battery.
Yep. So the zero line's right here. Yep, and then just further down in this particular example, you know, just turn some more stuff on and things like that. If anybody has looked at the little demo video, this is what was being done in that video. We can post a link to that. So that's literally just one channel out of that device, named current, and it doesn't really get more complicated than that.
But this is the kind of data you need if you're going to try to trace down any errant current draws in a vehicle or any type of system, really. And this gets you great resolution and visibility into what's going on with that vehicle.
Yeah.
So you can see what's happening, and then it's the process of maybe an elimination, pulling fuses on circuits to see which one finally kills your errant current draw. That's just normal technician techniques there.
And even in development, if you're just trying to, you know, benchmark things and verify current draws are expected, it's much easier. You could jump between a couple vehicles pretty quickly. You know, go screw the plant, move it to the next car.
Exactly.
You know, so it definitely helps with that. The one thing that I will say about current measurement in vehicles, it's all a matter of perspective when it comes to is positive consumption or supply of current.
Right.
Yes.
Right. And yeah, there's no issues with, you're running with a 48 volt system or
Yep.
or anything,
Doesn't matter.
clamp over a wire and it will show you whatever current is in the said
Yep.
wire.
Once you have that kind of visibility and that data available to you, that's when you can actually start solving problems.
Mhm.
And that's what we're here for, to help solve some problems.
Yep.
And certainly you'll be, your whole task will be much simpler if you can use an inductive style probe. Doesn't require a whole lot more equipment or anything.
Mhm.
It's just different and it's a newer technology. It's not terribly expensive. Shunts aren't cheap anyway. So, our inductive probes, they cost a couple dollars. Yeah, sure they do, but they don't give probes away or shunts away for free.
They're reusable. too.
Yes.
So
That's
the
right.
big thing with
Put it back in your
shunts
pocket,
is the labor cost to install them.
Yep.
I mean, if you're paying a shop to install shunts in a test vehicle, even if you've got your own technicians,
Yeah.
obviously 2 hours of technician time to install a current shunt is much more
Right.
costly than the minute it took him to screw a
Mhm.
probe on,
An inductive probe, yeah.
inductive probe over
Yeah.
a wire.
Mhm.
So
Thing is too, if you're looking to monitor some type of current for an extended period of time, you could use a CAN data logger, like one of our things, or like a capacitor memorator or something like that. Strap it under hood, and send somebody out to go on a drive or monitor on your drive home or something like that. You could do it in the parking lot. You don't need
That's
to throw it up on the lift or,
Yeah.
or anything like that. So it's
Literally that simple, that fast.
Yeah.
And,
Yeah, the top of it just it's like a little clamshell. Do a little set screw and it opens up like a clamshell. Put the wire through, clamp it back down,
and you're done.
plug it in.
Do you have any questions?
Yeah. No, I haven't seen any questions come in. But yeah, if there are any questions, we're getting to that point where we'll be able to take any kind of questions you guys have. Anything at all.
There's actually a time here that people can submit questions and we'll respond to them. You're not in this webinar, but we can get back to those people. If anybody has a question about anything here related, they can always submit that, and we'll see it. We'll get notified and we'll be in touch.
Yeah, either respond back to the invite that you received, or just ask. Use our ask support inquiry on our support portal. That goes to all of us support people, so we're usually pretty responsive to that.
If you need any information or help on selecting these inductive probes or data acquisition software, as we have some excellent options there, we'd be glad to talk to anybody about that, about their options and the different costs of those systems. And they can vary a lot, but depends on your needs. And we'd be glad to work with you and get you something that will support your program and give you great value.
We often do just provide demos to newer customers or any customer.
Yep.
Like, hey, I'm thinking about using this. Yes, we can provide you a demo, demo software, demo hardware, things like that.
Nothing like having it in your own hands.
Yeah.
Maybe you've got to convince your boss that it's a worthwhile investment, right?
Yeah.
So there's nothing like actually getting a sample there, installing it, and getting some data, and then going to the boss and say, hey, look, I set this up, took me 10 minutes. Boom, I got my data. We really should have maybe a selection of these devices on hand for testing in the future. We think that would be quite wise.
A question did come in from Robbie. It's actually a pretty good question. The question was, when the cable size doesn't fit through the probe, can it be left open? Unfortunately, no. That the clamp has to be fully closed and kind of click down 100%. But the picture that you saw there, that was I believe that was the one we were using. So that was a 100 amp. 100 amp probe, but they do go all the way up to 1000 amp. And then again, your the hole for the to pass the wire through will be much larger. So there are many different options. If you can't clamp onto a battery cable, if it's Too small, you just go up a size.
Yeah, and I've never seen a case where you really couldn't get that probe around unless you had really picked the wrong probe. I mean, if you were trying to put a 10 amp probe on maybe a double aught battery cable, yeah, sure, that may not work. But you probably should be picking a larger range probe anyway.
Right.
So I guess we should maybe make clear that you need to be clamping this over a single wire, not any group of wires.
Right.
Not even a pair. It needs to be over a single wire. So you may have to open up that harness in order to pull the wires out and be able to get access to a single wire that indicates the circuit that you're interested in.
Yep. Even if it might look like a single wire in a loom, it could be a power and a ground.
Yeah.
And if you clamp over those, you're not going to really read anything.
No, I guess you'd read the net current, which could be net zero.
Usually is.
Yes.
Yeah.